Hello math students, we've got some algebra going on again. In today's lesson we are going to solve multiplication and division inequalities. Make sure that you pause the video, copy down the notes, and then listen and write down the notes as I go through and explain each of the problems. Here we go. Here are the multiplication and division inequality notes. For the first example, it says, tell whether each integer is a solution of the inequality. So what we're looking for is we have the problem, negative 10x is less than or equal to 30. We're trying to find out which of these three solutions, negative 4, negative 2, or 1, or all of them, maybe none of them, which of those make a true statement. So what we're going to do is we're going to plug those numbers in to the original just to see which ones will be a true statement or which ones work inside of that inequality. So we start with negative 10 times negative 4 because negative 10x means multiplication. So I took the x out and I put a negative 4 in its place. So negative 10 times negative 4 is positive 40. Is 40 less than or equal to 30? No. So that means that x cannot equal, let's just backtrack that a little bit. So x cannot equal, so we put a little line through the equal sign. X cannot equal negative 4. Let's do the same thing. This time we'll put in negative 10 times negative 2. Negative 10 times negative 2 is 20. Is 20 less than or equal to 30? Yes. So x equals negative 2 would work as a solution for this inequality. Next we're going to test positive 1. Negative 10 times 1 is negative 10. Negative 10 is less than or equal to 30. Yes. So what I'm going to do on this number line is I'm going to start to put in some of those numbers that would work in this equation. So I've got the number negative 2 works, positive 1 works, but I know that negative 4 did not work, so I'm not going to color in a number on the negative 4. If we look at this problem a little bit closer, negative 10x, and we look at the equals part of this. If negative 10x equaled 30, we would do inverse operations and divide by negative 10. So x would equal negative 3. So negative 3 is going to be our point on the graph. That's going to be our end point on the graph, negative 3. And we've already tested a few of these points, so we can see that this arrow, this inequality, is going to go off to infinity to the right. So all of these numbers where x is greater than or equal to negative 3 would be our solution set. Okay? So that's what we're going to look at, is just put those, we're just putting those numbers in. If you notice the inequality on that one, the inequality started as a less than or equal, but once we got our solution, it was a greater than or equal. So in the note over here at the right, when you multiply or divide by a negative coefficient, remember the coefficient here was this negative 10. Negative 10 was that coefficient. When you multiply or divide by a negative, when that coefficient is negative, you must flip the switch. What that means is that less than or equal to changes to a greater than or equal to. Anytime you have a negative number and you're multiplying or dividing, if it's a negative coefficient, that's when that symbol gets switched. That inequality gets reversed. Okay? Let's take a look at the next example. So we're going to solve these just like we normally solve them, like we've been solving. We draw a line down that inequality. We're going to do an inverse operation. In this one, it's multiplication. It's negative 4 times the n. So we're going to use division to help solve this. So we get n on the left, and 60 divided by negative 4 is negative 15. Now, like we said earlier, this negative 4 is the coefficient. That's a negative number, so that means we need to change this greater than symbol into a less than. So all of the numbers that would fit into this problem would be less than negative 15. So we put a negative 15 on the graph. We leave it as an open circle. I'm going to put a couple more numbers on here. Remember, all number lines go least to greatest. And on this number line, all the numbers that are smaller than negative 15 get filled in. And of course, you can test this again. Test it on your number line. Maybe I want to pick a number way out here, maybe like negative 20. If we put that in, negative 4 times negative 20 is 80. 80 is in fact greater than 60, so it would make a true statement. So the arrow goes to the left, open circle on the negative 15. In the second example, we have a 1/2 times p. Okay, when there's a fraction times our variable, we're going to multiply by the reciprocal or use division. In this case, the 1/2 is positive, so we're not going to have to flip the switch because it's a positive coefficient. So if I multiply by the reciprocal, which is the same as a divide by 1/2, multiply by a 2/1, we end up with p greater than or equal to, we keep the same sign, and 9 times 2 is 18. We keep the same sign because the 1/2 was positive. It's a positive coefficient. So that means we need an 18 on our graph. Maybe we'll fit in with a 19, a 17, and a 16. In this case, we have a closed circle because it's underlined. P is not only greater than 18, it's also equal to 18. And all the numbers to the right, all the numbers that are greater than or equal to 18. Okay, and again, you can test some of those points as well. In the last example, we've got 54 is less than 9r. So again, you can draw your line down your inequality. Inverse operations here, divide by 9. Okay, and we end up with 6 is less than r. So we don't have to flip the switch on this one because that 9, that coefficient, 9 is a positive. So we leave the sign just how it is. We can leave this as 6 is less than r. If we read this backwards, r is greater than 6. So I need a 6 on my number line. It's an open circle since it's just, it's not underlined, it's an open circle. R is bigger than 6. So I fill in all the numbers all the way out to infinity that are greater than 6. Again, you're going to want to put a few numbers just to show that your number line always goes least to greatest. If you have any questions, watch the video again or ask your teacher. Thank you.